Everybody, good afternoon. How are you all? Welcome to Infinity Learn by Sri Chaitanya. My dear students, as we discussed in our session, we are going to do Chak Day is the title. I think you know in this series, mine is going to be almost the first class in math. You see, as I told you yesterday, dear students, I have picked a very important topics, especially for main and advanced, with respect to weightage, with respect to easiness, and with respect to the difficulty level felt by the students. Vectors, 3D, matrices is a very good combination from where you will get minimum 5 questions in mains and at least 3 questions in advanced. So, these topics seems to be very easy, simple. Of course, they are easy, simple, at the same time very important. My suggestion to the students is please don't neglect this topic. One important point related to vectors is if you are good at all the concepts and basic formulae of vectors, at least NCERT level, and if you could do some set of 100 problems related to objective questions, it's very easy to attempt. That is enough to attempt question in mains and advanced. That is the speciality of the topic vectors, even 3D also, right friends. Here let me recall the important points first just in brief and we shall start the topics. I have taken the vector algebra lesson into 2 parts, that is vector algebra 1. Here I am going to discuss only vector addition part, and in the next class some dot product, cross product, triple product followed by miscellaneous problems will be discussed, right dear students? Fine. Okay, so I think before that, before we start the lesson, please don't forget to subscribe to our channel Infinity Learn, right? Fine. Okay, yeah. What are the important points? I tell you friends, first let us recall certain definitions and important points related to this. First one, you know these two words, scalar and vector. You know, scalar is a quantity which has just magnitude, and vector is a quantity which has magnitude as well as a direction. I am not going to talk beyond these things, you know already. Since it is a recap, I will give in brief itself. You know, vector will be represented, a vector will be a directed line segment, say AB, in the space. It has certain magnitude, it has certain direction, right? Fine. Sometimes we also write maybe like A bar, you know the notation. When can we call two vectors are equal? Two vectors are said to be equal if they have same magnitude and same direction. Suppose I may take another vector CD bar. Suppose they have same magnitude and same direction, I can say these two are equal vectors. Friends, you must remember vector is a directed line segment. You see, without changing the direction, that vector can be moved anywhere in the space. Yes, it is not a localized vector, so you can just take the vector by fixing this particular magnitude without changing the direction, you can move anywhere in the space. This is an important point to understand vectors. Next, unit vector is that vector which has unit magnitude, that is 1 unit. For example, A bar is any vector, you just divide by its magnitude, you will get a unit vector we denote by A cap, right friends. Then directed line segment, just now I have told vector is a directed line segment. This idea is the most important one. Then what do you mean by, yeah, Teja, good afternoon, yeah, right. And like vectors and unlike vectors. Two vectors are said to be like vectors if they have same direction, unlike vectors if they have opposite direction. Suppose this is A bar, may not be having the same magnitude if the direction is same. A bar and B bar can be said as like vectors. So let me take another vector in exactly opposite direction. We can call these two vectors are unlike vectors. That's it. Yeah, Manish, hi. So I'm just telling about the basic terminology. So what is scalar, vector, equal vectors, unit vector, what is we can understand vector as a directed line segment as well as like vectors and unlike vectors, okay, fine. So after this, dear students, the next one, coplanar vectors. If certain vectors, if there exists a plane passing through these vectors, they can be called as coplanar vectors, friends, like this. That means, you see, you have taken one vector of this way, one vector of this way, there may not exist a plane passing through these two. So generally line segment, but vector is a line segment, so you can move in this way such that you can make it like an intersecting lines, there exists a plane passing through them. So any two vectors are always coplanar, whereas three vectors may not be coplanar. Just you imagine like the three corners of a room, or I cap, j cap, k cap, as you are already familiar with, they are not coplanar. That means through the given vectors, if there exists a plane passing through them, we say that they are coplanar vectors, otherwise non-coplanar vectors. Yeah, right. Find then angle between vectors. This is an important idea, friends. If two vectors are taken, say A bar and B bar, yeah, if theta is the angle, automatically this will be 360 minus theta. Which angle should be taken? A bar, angle between A bar, B bar is denoted by like this. This is the notation. So we take angle as theta such that 0 less than or equal to theta less than or equal to pi. This is very, very important point, my dear friends. Angle between two vectors should be closed 0 to pi. You cannot take more than pi. So, and what is the angle between B bar and A bar? In fact, it is also theta. It is not like anti-clockwise direction, clockwise direction, such concept is not there. Angle between two vectors means you just take like this, you just take the angle which is from 0 to 180. That is important point. Friends, if A bar, B bar are two vectors, suppose the angle is theta, suppose you have multiplied A bar with m, B bar with n, ma bar, nb bar you have taken. If m is positive, n is positive, the magnitude either increases or diminishes in the same direction, but the angle will not change. This is same as angle between A bar, B bar, if m is positive, n is positive. Yes. Suppose both mn are negative, so suppose B bar negative direction means it comes like this, A bar negative direction it comes like this, but still the angle is theta itself. If both m comma n are positive or both m comma n are negative, there is no change in the angle. Whereas if m n are such that one positive, one negative, suppose A bar is like this, minus B bar is like this, in that case the angle is nothing but pi minus theta, pi minus theta. Let me repeat, friends, this is very, very important point. If the angle between two vectors A bar, B bar is theta, then the angle between MA bar, NB bar is theta. If Mn have same sign, and pi minus theta if m and n have opposite sign. That is the point, my dear friends. So this is an important observation, right? Suppose, friends, if you take two like vectors, we can say like vector same direction, so angle is 0. If you take two unlike vectors exactly opposite direction, we take the angle to be exactly pi. So angle pi is also possible, angle 0 is different, angle pi is different, friends. Please do observe. That is another important point. So angle between two vectors is done. Now coming to the points, dear students, yeah, vector addition. So yeah, Anshupriya, yes, today due to some technical reason I couldn't attend at 2 o'clock, so this is why I planned the session at 4 o'clock. So inconvenience is regretted, but I'll try to stick on to the schedule, okay, right? Yeah. Now vector addition, dear student, I really appreciate your seriousness, Anshupriya and Manish and Teja, all of you. You please continue the tempo. I'll give the best possible input. I just want those students who seriously taking part into the class. Really, I like you, really, my dear students. Yeah. So vector addition, adding two vectors. You already know two things, friends. We call here triangular law and parallelogram law. If you take two vectors, friends, suppose this is a bar here, there is some other vector b bar here. How to add these two vectors? One thing I already told you, without changing the direction of b bar, you can move it anywhere. If you just bring b bar here, friends, suppose this is b bar, this can be moved. So I brought such a way that a bar is at here ab, b bar I brought here without changing the direction. Suppose they have the same direction. So here end point is same as the starting part of the second vector, say BC, suppose. Now the addition is defined like AC bar. That means if you are adding two vectors such that AB bar, second is BC bar, the end point is same as the starting point of the second. In that case, we define vector addition as AC bar. That's all, right? Yeah. The next, suppose in the same situation, AB is here, A bar is here, suppose B bar is here. Instead of bringing this part here, if you bring here, suppose this is B bar. Now you want to add two vectors such that you see both have same initial point. In this case, we define the addition like complete the parallelogram. We define this diagonal as A bar plus B bar. This is called triangular law of addition. This is called parallelogram law of addition. Rather the big sentences, it is very simple here. If you are adding two vectors, you just see if ending point is same as starting point, join like this. If you want to add these two, if they have same initial point, complete the parallelogram with these two sides, then take this diagonal. That is, if this is B bar, undoubtedly this is B bar, this is A bar plus B bar, right friends? Yeah. After this, you know vector addition is commutative, associative, 0 bar is the additive identity, A bar's additive inverse is minus A bar, all the properties will be there just like in real numbers algebra, right? Even you know multiplying a vector with a scalar, A bar multiplied by L, you know. So all these simple operations you might have already familiar with. I am not going through those in detail because you may feel little bored with that. Fine, good. Then after this, friends, we have done these three. Then linear combination of vectors. So linear combination means, dear students, you see, suppose A bar is a vector, B bar is a vector, C bar is suppose another vector. You just choose some real numbers elements such that LA bar plus MB bar plus NC bar. This expression is called a linear combination of these three vectors A bar, B bar, C bar. Okay. Then next, when do you call certain vectors are linearly independent, certain vectors are linearly dependent? Friends, suppose you have taken A bar, B bar, C bar, three vectors. These are said to be linearly independent if whenever you choose a linear combination is equal to 0 bar, if it implies that L, M, N must be 0, otherwise impossible, then the vectors are said to be linearly independent. For example, I cap, j cap, k cap are linearly independent. Their sum is 0 bar is impossible because that is impossible. So they are linearly, it is possible only when suppose L I cap plus M j cap plus N k cap is 0 bar, in the sense L must be 0, M must be 0, N must be 0, otherwise impossible, right. Linearly dependent means, friends, linearly dependent means if there exists a linear combination, suppose we call these three vectors are linearly dependent, there exists some linear combination Lmn where not all 0 but La bar plus Mb bar plus Nc bar is equal to 0 bar. Lmn not all 0, there must exist, like for example I cap, j cap, I cap plus j cap as a linear, they are linearly dependent because some vector can be written in the linear combination of other two, that is the meaning. If you don't understand in detail, no problem, just I will tell you, if A bar, B bar, C bar are expressed in ijk after some time, linearly independent means the determinant is not equal to 0. Linearly dependent means det is equal to 0. Please try to remember that single phrase. So, in the later stage we are going to do problems on this. If A bar, B bar, C bar are vectors in terms of ijk, consider the corresponding determinant or what we call box. If that det not equal to 0, linearly independent, det is equal to 0, linearly dependent. Those two phrases are enough. Even though you don't understand in detail, no problem, you can attempt the question in the exam, right? Fine. Next, right handed system, left handed system, orthogonal triad and orthonormal triad. Simple, friends, I am not going into detail. Right handed system, suppose you are given A bar, B bar, C bar. Actually right handed system means actually like A bar, B bar, C bar in the order. In this order we say that right handed system, actually from when you see from A bar, B bar to C bar, angle must be less than 180, like that some lengthy definition would be. We don't require this. I don't want to confuse you. If three vectors are given, simply take their determinant. Same order, you should not change the order. If this determinant is positive, we say that those three vectors are forming right handed system. So, right handed system. If the det is negative, we say that they form a left handed system. Okay. Right. Next, of course, orthogonal means after forming right handed system, if they are mutually perpendicular to each other, that means A bar perpendicular to B bar, B bar perpendicular to C bar, C bar perpendicular to A bar, we say that these three vectors are orthogonal vectors. Orthonormal means they must form a right handed system. Orthogonal, apart from these must be unit vectors, unit vectors. In that case, we say that the three vectors in the same order orthonormal vectors. Okay, simple, friends. One thing, you are given three vectors A, B, C in I, J, K, linearly independent or dependent. How will you do? Take the determinant. If not equal to 0, independent, equal to 0, dependent. Point number 1. Number 2, right handed system or left handed system, we take the determinant. If positive, right handed system, negative, left handed system. Orthonormal means basically they must be unit vectors. Angle must be 90 degrees between any two vectors and they must form a right handed system. Okay, friends. Then next, after this, of course, every vector we take the Cartesian system. So, x axis, y axis, z axis, and now we can take any point p, x, y, z. In 3D geometry we call the point p, x, y, z. Here we call a position vector OP bar. We read it as a position vector. It is very important when we read a question in the topic vectors, whether he has given a point are a vector. Both will be in the vector notation, but read the question carefully. I will show you some problems, right. If this is the point P, X, Y, Z, my dear students, so every point can be represented as a vector, of course in terms of I, J, K. You know, unit vector in the direction of x axis is I cap, in the direction of y axis is j cap, in the direction of z axis is k cap. Every point in the space can be represented as a linear combination and I, j, k. That is one point. And I think you know friends, if you are given two vectors, say a bar, b bar, if you want the point which divides a bar, b bar in the ratio m is to n internally, just like in 3D geometry, mb bar plus na bar by m plus n. Externally, if you want, we just write minus here. If any of you have any doubt, please let me know. Otherwise, these are all basic and standard one. If you want the midpoint also, simply m is equal to n, it will be a bar plus b bar by 2. And centroid, suppose if you are given three vertices of a triangle, points, vertices means points, points. If you are given three vertices of a triangle, the centroid is going to be the average point a bar plus c bar by 3. And it is very, very important to know the centroid of a tetrahedron. You see friends, you are given a triangle, base triangle, say ABC, the top is a point D, you just join, you will get a figure called a tetrahedron. Base is a triangle, top is a point, I have joined. Friends, what do you mean by centroid here? Yeah, centroid means, suppose this is one vertex, take the centroid of the opposite face triangle, say G1, okay, G1. You just join these two, let us call it as median 1. In the same way, B2 opposite this, second median, third median and fourth median. There will be 4 medians, all the 4 will be concurrent at a point, we call it as centroid of the tetrahedron. You know this point G divides any median in the ratio 3:1 internally. This is also important point. Centroid of a tetrahedron means that two results. How to find centroid of a tetrahedron? It is a bar plus b bar plus c bar plus d bar by 4, as well as friends I can say another point. Yeah, sure. Manish, I've seen you somewhere, right? Fine. So, and this point, divide this in the ratio 3:1 internally. Okay, right. Then DCs and DRs, this is very, very important thing. We study vectors with the help of 3D, 3D with the help of vectors. Suppose friends, if you take, if there is a line, if the angle connecting with the angle made by the line with x-axis is alpha, y-axis is beta, z-axis is gamma. So, I think you know, what can you say about alpha plus beta plus gamma friends? Can anyone? Can I expect the answer? Anshupriya, Manish, can I expect what about alpha plus beta plus gamma? Can I expect the answer? Alpha plus beta plus gamma. If there is a line I have taken at the corner, suppose the line makes angles alpha, beta, gamma with the coordinate axis, what can you say about alpha plus beta plus gamma? Can you say, can I expect the answer? You can just type, I am just, let me know. So, with this I can understand. Yeah. Can I? Pi. Okay. Manish, can you say the answer? Well tried, Anshu. Manish, can you say the answer? Yeah. In fact, one point is alpha plus beta plus gamma is not constant. Like in 2D geometry, alpha plus beta plus gamma is not constant. First, it is foremost important point, friends. Here, yeah. So I mean to say, so these are the things. If the angle with x-axis alpha, beta, gamma, we call cos alpha, cos beta, cos gamma. These three numbers are called direction cosines. Yeah, direction cosines. So the relation connecting them is cos square alpha plus cos square beta plus cos square gamma is equal to 1. The next, friends, after this, yeah, so any numbers proportion to direction cosines, fine. Great, that's great. Good. Yeah. So any numbers proportion to alpha, beta, gamma can be called as direction ratios. Fine, friends. Suppose for a particular line, direction ratios are 2 to 1. How do you write direction cosines, friends? I think you know, you just divide with root of a square plus b square plus c square. So this is going to be, yeah, 3, 2 by 3, 2 by 3, 1 by 3. These are the direction cosines, and of course you can also take minus 2 by 3, minus 2 by 3, minus 1 by 3 as direction cosines, right, dear students? Yeah. So after this, vector equation of a line and vector equation of a plane, these will be discussed at the problems, right? So with this, friends, I have given the very brief introduction of I recollected all the important points related to vector addition. Yeah, then let us move to the problems, right? You see the first question here, AB bar is given, CB bar is given, CD bar is given, I want AD bar. How to find? So friends, AB bar is given, CB bar is given, CD bar is given, I want AD bar. Friends, one thing I can say, AB bar plus BC bar plus CD bar gives AD bar by just vector addition, right? AB bar is given, I just write 2 minus 3, 1. CB bar is this, so BC bar will be minus 1, minus 1, minus 1, plus CD bar will be 4 minus 7, 0, right? Yeah. Now you are going to get AD bar. Simply it is going to be 6 minus 1, 5, minus 10, minus 1, minus 11. You just keep observing the options. 5 minus 11, 0. Option B is the answer. Right, friends? You are given 3 vectors. He is asking AD bar. Right, friends? Good. The next, you see this question? You are given A bar, B bar, C bar. If a vector R bar is collinear with C bar and R bar's magnitude is magnitude of A bar plus B bar, then R bar is equal to, right, friends? See this question, what is given? A bar is given, B bar is given, C bar is given. R bar is a new vector collinear with C bar. Yes, C bar's collinear means, you see, R bar must be some number into C bar first of all. Yes. So whereas R bar's magnitude is nothing but A plus B's magnitude. So magnitude of R bar is magnitude of K into C bar. So this is magnitude of A bar plus B bar is equal to, you can say, mod K into magnitude of C bar, right? So that you can find K. So A bar plus B bar you can just find, friends. A bar plus B bar you find 5 plus 1, let me write directly, 6, this is minus 2, this is going to be minus 4. Whereas its magnitude is going to be 36 and 40, 56. Am I correct? Yeah. So root 56 is equal to mod K into, what is magnitude of C? 9, 10, 14, root 14. So this is going to be 2. So mod k must be 2. So initially we have taken that r bar is nothing but mod k into c bar. So k is 2 means you can take 2c. Collinear means it can take same direction or opposite direction even. So plus or minus 2c bar. Am I correct? If somebody could do faster than me here, you can post the answer. I will be very happy, right? Yeah. Good friends. Simple questions but basic thing. So the reason is if I could, I can pick up the higher order problems, but the thing is you just see the previous archives of JEE mains or advanced. If you are comfortable with all the mains, main operations, main concepts related to vectors, you can definitely attempt the question from this particular topic, right? Acha chalo. You see this question, try this question. R bar is given, 2r bar is also given. Okay, fine. Then r bar, q bar have the same direction, opposite direction, one particular operator here, then magnitude wise he is comparing. Okay, first thing you can see, are they having 2r bar means not a big thing. You can just see what is this, p bar minus 3q bar. So he is comparing r bar and q bar. That means, any idea? Sure dear Newton sir, will take. So I am happy to have Newton in my class, right? That's great. Yeah, fine. Yeah, right. My point is, dear Newton, my point is, if you do the total lengthy topic permutations, of course you will be getting one question in mains. If you do vectors, 3D, matrices part, you will be getting minimum 4 to 5 questions. Intelligent planning should be there, right? This is why we have taken up these questions first. So I think, dear Newton, we have in the same Infinity Learn platform, we are having permutation combinations related revision classes. You can go through this integral solutions, and we have given special video related to especially division and distributions of balls into boxes, integral solutions, higher order advanced questions are discussed. You can go through, I will try to provide that video link, right? You can go through that video, right? Fine. Okay. So here in this particular question, you can observe that r bar and q bar are compared, right? So you can do, what you can do is eliminate p bar from these two, so that you got almost the relation. So p bar, how to eliminate? You see, 2r bar, here you can write r bar is equal to 3p bar plus 4q bar. From this, p bar is nothing but 2r bar plus 3q bar. So you replace, p bar is nothing but 2r bar plus 3q bar plus 4q bar, which is going to be, friends, this is 6r bar minus r bar is 5r bar. This is 9 plus 4, 13, which is equal to minus 13q bar. So which is, friends, r bar is going to be minus 13 by 5 q bar. This is the point. If r bar is minus 13 by 5 q bar, so definitely one vector is some negative number into other vector, means they will be in the opposite direction. You can take out a bar and d bar. Now what about its magnitude? It is more than 2 times, right? So this is q bar is multiplied by 2.6 into r bar magnitude wise. So this is smaller, this is r bar magnitude is greater than the double. So you can opt with option B, right? Yeah, right. Anshupriya and Manish able to follow, and all the other students who are here, I think you the following things, right? Clear? It's very simple. The first observation in this problem is you see the options. In all the options he is comparing R bar and Q bar. So try to eliminate P bar, you got the relation, that's it. Clear? Right? Fine. Next, you see this question. Yeah. The vectors, you see first vector, second and third have their initial point at 1, 1, the value of lambda so that the vectors terminate on the same straight line. Good, you try this problem. Can I expect? Just I'll give little time, you just try this problem. First try to understand the question and try to find the value of lambda. Yes friends? You see these three vectors have their initial point at 1, 1 and the value of lambda so that the vectors terminate on the same straight line. Yeah, right. Okay, so the problem is, you see, first drawing the figure is important here. So that means you can take a line like this. So first vector, second vector, third vector, there are three vectors here having the same initial point 1, 1. So here you can observe that k cap is not there, in the sense you can treat the problem in xy plane itself, third coordinate is not there. So you can put 1, 1, 0 also, or you can take the entire problem in xy plane. It's a 2D geometry problem. Now the first vector has initial point 1, 1 means, you see this vector is 2, 3 means what should be this point? 3, 4, because this difference is going to be 2, 3. Am I correct? So this vector is 5, 6 means this must be 6, 7, right? The next, this vector is 8, lambda, in the sense this must be 9, lambda plus 1. Yes. Now these 3 points lie on the same line. It's a straight lines problem, 3 points collinear. So that means slope of AB is equal to slope of BC, kind of. What is the slope of this? 7 minus 4 is 3, 6 minus 3 is 3. The slope is 1, whereas this slope must be lambda plus 1 minus 4 you can take, or lambda plus 1 minus 7, that is lambda minus 6 by 9 minus 6 is 3. So you are going to get lambda is equal to 9. That's all. Simple. You just see this question, friends, not at all difficult. The only thing that we have observed is, you see, he has given 3 vectors, okay, right? Yeah. So initial point is given, right? So even terminating points we just require, indirectly, you just see most important point is he has given the point or vector. Understanding that is very, very important. He said 3 vectors, initial point means it is not a point, it is a vector, so you need to find the terminal point. All the terminal points on a line. So friends, do remember, you see, in market there will be many things which are very attractive. The original will be conceptual, right? You see, my point is, dear students, I tell you, out of 13 lakh students who are writing the exam, JEE main, the number of students who could cross 40 marks in an average I am talking about, who are crossing 40 marks out of 100 is just 30,000. Yes, really. Yes, it is just 30,000. What is the reason? You see, there is a slight difference between math, physics, chemistry. So because of this negative marking, suppose in physics or chemistry, if you are not aware of the answer, you will be clear that इसका answer मुझे नहीं पता है, इसे छोड़ना है. You will be leaving that question. But whereas in math, the problem is we feel that we got the answer. We feel that it is very easy. In fact, It is not easy, and unfortunately with the limited knowledge what we have, we will be trying the problem and we come across an answer which is wrong, will also be available in the option. That is the problem. It is like math paper will be like a spin bowling, right? Once if you are not clear about a concept at one particular point, it can easily mislead you to certain point. Yes, you see, you said something when I teach some synopsis, something you said speed up something, that's good. I think you are perfect. I don't think you are thorough with, but the point is, if you are not clear about each and every concept basically, especially in these topics where we are expecting good number of questions, you see friends, definitely you will be misled to some other answer. So with the limited experience what I have, let me tell you friends, I have given instruction to many of my students. You know, in advanced paper, you see, out of 2.5 lakh students who qualify for advance, 1.5 lakh students only attempt the exam. 1 lakh students either they don't apply or they don't attend the exam. Out of these 1.5 lakh, I tell you, see the statistics, the student who get minimum marks in each subject, math, physics, chemistry and total, it is around 10% only. Altogether it is 45,000 only. Many students are not getting minimum qualifying mark in subject wise also. In such case of students, why not? Yeah, Subiksha, good evening, good evening. Yeah, why don't you, I mean to say, why don't you plan in intelligent way? Hi, why don't you plan in intelligent way? You see, it is many teachers feel that, many coaching institutes feel that giving higher order problems is advanced. Nonsense, not that thing. That formula will not work out for everybody. You see, an intelligent student who could score 50 marks in mains, especially girls I am talking about, dear students, if you could score around 30% in advance, you will be in IIT. Yes, it's a fact. Go through the statistics. My videos are available. My advanced videos are available. Strategy videos are available in Infinity Learn platform. So don't be misled by some other. You just have intelligent way of. You see, if I am teaching a particular problem slow, means there is some reason. There is some point. We can also go very fast, but no use. Do remember, learn the concepts well. So I mean to say, you will gain lot many things, right, dear students? So tune to my flow. You will enjoy the things, right, dear students? Fine. Anyhow, suppose I can also bring some higher order 10 to 15 problems in vectors. If I discuss and go, that's fine. So you will say, अरे यार बढ़िया बताया sir, बहुत अच्छा problem लेके आए, वो बताया ये बताया, fine. But what about the result? Result oriented coaching is the specialty of Infinity Learn, dear friends. Just follow me. After 2 months, after you write March exam, first attempt of March JEE main, you just ask me. I will be taking the classes. You ask me, अरे बशीर तुमने बताया, वो बताया, ये बताया, ऐसा क्वेश्चन नहीं आया, वेक्टर से क्वेश्चन नहीं आया, very hard क्वेश्चन आया, बताओ तब देख लेंगे, right? Fine, friends. You just follow me. Believe in me. I'll give the best input, right? Fine, dear students. Yeah. You see this, A bar, B bar, C bar, B, distinct non-negative numbers if the vectors, first vector, second vector and third vectors lie in a plane, then C bar is. Arey yaar, 3 vectors are in a plane means coplanar, all the 3 are in IJK, single point. What is that? 3 vectors coplanar, 3 vectors coplanar, only 1 point, friends, that is equal to 0. 3 vectors, you just remember it as a mnemonic, 3 vectors coplanar, that is equal to 0 with IJK. You just apply the determinant A, C, 1, 0, 1, C, B. This that is 0, it is enough. Yes. Now friends, A into 0 minus c is minus c minus a into b minus c plus c into, you can write c. So friends, minus ac minus ab plus ac plus c square is equal to 0. So minus ac plus ac is gone, c square is equal to ab. What is the conclusion now? So c square is equal to ab means c is the geometric mean of a and b. And to say geometric mean, you see, I guess it is geometric mean because generally when we talk for geometric mean, it is for non-negative numbers. For arithmetic mean or harmonic mean, non-zero number, of course arithmetic mean can be defined for any, harmonic mean is defined for non-zero numbers. As he said, non-negative, in the options arithmetic mean is there, geometric mean is there, harmonic mean is there. Suppose I always have the idea that if I don't know any answer for any particular question, I never attempt in mains or advance. Suppose still I want to go, one or two questions I want to go, I want to guess, so I will go with geometric mean, because friends, non-negative is for geometric mean, because square root of a negative number is not defined. Simple clue is there in the problem, please do observe, that is very important. And after all, in this problem I want to say one important point, my dear students. 3 vectors coplanar, that is equal to 0. Clear? Clear friends? 3 vectors coplanar, that is equal to 0, right? Chalo, next problem. Yeah, coming to this point, this is another important point friends. 4 points, point 1, point 2, point 3, point 4. 4 points are coplanar, then what condition you are going to get? Arey yaar, 4 points means very important. 3 vectors coplanar, their box is equal to 0, that means det is equal to 0. So 4 points coplanar means friends, 4 points A, B, C, D, you just convert into 3 vectors AB bar, AC bar, AD bar. Now it is just a previous problem. You see, all the 3 points are alike, this is bit different, so you consider, let it be, yeah, A, B, otherwise B, C, D, A you take. AB bar you take, this minus this, what will you get? Friends, 1 minus x, this is 1, 1, yes. So you can take this minus this, I have done, 1 minus x, 1, 1. This is going to be same way, 1, 1 minus y, 1. 1, 1, 1 minus z. You see, even though we write like this, these are vectors, those are points. 3 vectors coplanar, that is equal to 0, that 1 minus x, 1, 1, 1, 1 minus y, 1, 1, 1, 1 minus z. This is 0. Now it is a determinant problem. Yeah, this is determinant problem, right? So how to do it? You just see the options, you can any idea to do. You see, you can just take x common, y common, z common, so that you might have gone through this particular determinant. So this becomes 1 by x minus 1, 1 by x, 1 by x. I have taken x common. So one thing, let me take out this. Yeah. You take this problem like that 1 minus x, 1, 1, 1, 1 minus y, 1, 1, 1, 1 minus z, that is equal to 0. He said these points are coplanar alpha, then what condition you can say? He should give x, y, z should not be 0 friends. If x, y, z should not be 0, you can take x common here, this becomes 1 by x minus 1. So you can write 1 by x, 1 by x. I have taken x common from first column. Then similarly y common here you take 1 by y minus 1, 1 by y minus 1 by y. Here 1 by z, 1 by z, 1 by z minus 1. This that is equal to 0 friends. So here of course x, y, z will be. In the problem he should mention that x, y, z not equal to 0. Of course he has written x, y, z in the denominator. Now friends, what you can see, you just add column 1 as column 1 plus column 2 plus column 3, so that 1 by x plus 1 by y plus 1 by z minus 1 at each and every, you will be getting 1 by x plus 1 by y plus 1 by z minus 1 common, right. Then after taking common here 1, 1, 1 will be left. Then here it will be 1 by y, 1 by z, 1 by y minus 1, 1 by z, 1 by y, 1 by z minus 1. So either this must be 0 or this must be 0. You can use, with the help of this, you can subtract here. This is equal to 0 means option B is one possibility. We can prove that this det is not equal to 0 by taking the operations R2 minus R1, R3 minus R1. 1 by y, 1 by z. This becomes 0, minus 1, 0. This becomes 0, 0, minus 1. It is a triangular matrix. Product of this determinant is 1. I mean, product of the elements of the diagonals gives the determinant. So this is going to be 1. So friends, this is going to be the answer. So friends, this problem is combination of determinants as well as vectors. Only 2 points friends. 3 vectors coplanar, that is equal to 0. 4 points coplanar, convert them into 3 vectors, that is equal to 0. The same concept again we use in 3D geometry. It is not a different problem in 3D geometry again, my dear friends, right? Fine. Next. Yeah. You see this question, my dear friends. If a non-zero scalar, okay, the vectors alpha bar, okay, and p bar and r bar are coplanar, if a negative, a positive, always coplanar, never coplanar. You see, he has given alpha bar is written in terms of, you see, a, 2a, 3a, p bar is written in terms of 2a plus 1, 2a plus 3, a plus 1. See, this kind of determinant problem only, no? 3 vectors he is asking whether coplanar or not. Just let me give the idea of this. First vector a, 2a minus 3a. Second vector p bar 2a plus 1, 2a plus 3 and a plus 1. Then third vector 3a plus 5, a plus 5 and a plus 2. You just need to compute this determinant. For this, my dear student, with the help of this double and subtract you do, you just find the determinant. The final determinant you just observe, it comes in terms of a. So that a you observe, if that is, I can say, not equal to 0, suppose always coplanar means if it is equal to 0 irrespective of a, always coplanar. If it is an expression which is never 0, never coplanar. Otherwise you can comment based on the determinant. Will you handle this determinant, friends? Will you handle this? It's kind of determinant. With the help of this you can, of course friends, you can take a common here. I think 1, 2 minus 3 and this becomes 2a plus 1, 2a plus 3, a plus 1. This is 3a plus 5, a plus 5, a plus 2. Now you can make it 0, add these 3 here, you will get 0 here, some number here. Double and subtract, it is easy to expand, you just do, right? I think all of you can do this part, right, dear students? Not a big issue. You may get a quadratic expression in terms of a. For a quadratic expression, if delta is negative, which is always positive, such kind of expression may also come. You just try this, I think you can solve it, right? So let us try to touch few other models also. Right, dear students, you see this question. Now, ABC be a triangle and let DE be the midpoints of the sides AB, AC respectively, then BE bar plus DC bar. You see friends, ABC is a triangle, fine, okay, sorry, ABC is a triangle, DE be the midpoints of the sides AB and AC, okay, these are the midpoints, good. Then BE bar, okay, this vector plus DC bar, DC bar, this vector, he is expecting all are in terms of BC bar, my dear friends. Okay, so what you can do is, you see, you can choose, you can do one thing friends, you can take here one of the vertices as 0 bar and give name to all the other. You know why friends? You see, from this point 3 are going this or this. I take this as 0 bar, you can take anywhere of course. I name this point as C bar, this point as A bar, so that since this is the midpoint, this is C bar plus A bar by 2, this is 0 bar plus A bar by 2, this one. Now you see friends, how will you write BE bar? BE bar means OE minus OB, which is C bar plus A bar by 2 itself. How will you write DC bar? DC bar is OC bar minus OD bar, which is A bar by 2. So you just find friends, A bar by 2 gets cancelled, you will get 2C bar. When BC bar is nothing but C bar only because it is 0 bar. So 2C bar is going to be the answer in terms of BC bar. You just see, sorry, C bar plus C bar by 2 is 3 by 2 C bar. Yes, 1.5 C bar. So 3 by 2 BC bar is the answer. So this is an important technique to handle such questions. If possible, you try to give one of the vertices as 0 bar, then you give others as points, convert into vectors and do. Right friends? Clear? Fine. The next one, you see, the adjacent sides of a parallelogram are given, then the unit vector parallel to a diagonal. Yes. You see friend, there is a parallelogram. Suppose A, B, C, D. He has given adjacent sides, he said. So this vector, not points, do remember. This vector I write 2, 4, minus 5. This vector 1, 2, 3. Friends. Now the diagonals. I think my dear friends, you know, in a parallelogram, suppose this is A bar, this is B bar, this will also be A bar. So friends, this vector is going to be, this diagonal is going to be B bar plus A bar. Yes, this is going to be B bar plus A bar. So what about this diagonal? This is nothing but you travel from this way to this way, minus A bar plus B bar, minus A bar plus B bar. So friends, the diagonals in a parallelogram will be A bar plus B bar, one diagonal. Of course, if you take in this direction, if you take in opposite direction, minus A bar minus B bar. This will be B bar minus A bar, or if you take in this direction, A bar minus B bar. So as he has given two vectors as sides of a parallelogram, the diagonal in the sense he is asking the unit vector. Fine, okay. Suppose if he is taking this vector, you just add these two. This is going to be 3, 6, minus 2. So is that combination is there? 3, 6, minus 2 or minus 3, minus 6, 2 is also okay. That is not there. So you might have taken another diagonal. So A bar minus B bar you do 1, 2, minus 8. Is this combination is there? 1, 2, minus 8 or minus 1, minus 2, 8, that is also there. Yes, this combination is there. Obviously you would have taken the unit vector 64 plus 4, 68 plus 1, 69. So D is the answer, my dear friends. In this problem, two important points are given. Point number 1 is, dear students, when you are given the two adjacent vertices of, adjacent sides of a parallelogram like A bar, B bar, one diagonal is A bar plus B bar and the other diagonal is A bar minus B bar. Of course, B bar minus A bar. For the same diagonal, this direction will be there. No. If one is A bar minus B bar, other is B bar minus A bar. One is A bar plus B bar, the same opposite direction is minus A bar minus B bar. So this is the point, friends. The next, you see friends, in triangle ABC, what about if G is the centroid of triangle ABC? Just try to answer this question, friends. G is the centroid of triangle ABC. Now what can you say about GA bar plus BG bar plus GC bar? Yes. What way you can do? GA bar plus GB bar plus GC bar. Yes. One thing, why don't you take G bar, G itself 0 bar, let it be A bar, B bar, C bar. So friends, G is nothing but by formula A bar plus B bar plus C bar by 3, which is given as 0 bar. So I can say A bar plus B bar plus C bar is 0 bar, let it be there. Now according to the problem, GA bar means, yeah, this is going to be, yeah, A bar. BG bar means this is GB bar is B bar, BG bar is minus B bar, okay. GC bar is C bar. This one he is asking about. You see friends, this is A bar plus C bar minus B bar. You just add B bar and minus 2B bar. So minus 2B bar you can write, yes. B bar is nothing but GB bar and minus B bar means BG bar. 2BG bar is fine among the options. D option is okay. It is a very simple and easy technique to handle such geometry questions. Choose one of the vertices, one of the points at 0 bar. You can also do this problem by choosing origin at B bar or C bar or A bar, no problem. Calculation wise there may be some change, but friends, you will get the answer. It's very important in JEE main and advanced is you must have certain chapters to be your most favorite. You needn't be thorough with 100% of the syllabus, right? So whatever you are liking the chapters, those chapters you do at most depth, because to get seat into IITs 40% is enough, yeah. Yes. 2021, a student who scored 50% got 2500 rank in advance. In 2020, a student who scored 50% got 1500 rank. Yes. So intelligent planning. Yes. Whatever you are learning, learn in a perfect way. There must be certain favorite chapters for each and every student in each and every subject. If you are having love and affection with 40% of the chapters, it's enough you are in IIT. Yes, my dear student. Yes. Yeah. So friends, next one, you see this particular question. The value of A for which the points ABC with position vectors, please do remember, what did he give? With position vectors, the point ABC, sometimes he won't give this phrase, the value of A for which ABC with position vectors he say. That means he has given 3 points, yes, not vectors, 3 points. A vertices of a right angle with angle C is to be pi by 2. So what the possibility of K? I think you can do this, not a big issue. So C must be 90 degrees. So AB here, you are given the point A point is 2 minus 1 1, C point is A minus 3 1 and B point is 1 minus 3 minus 5. Fine friends, now this is perpendicular. If you apply perpendicularity condition, you will get the value of A, right? He is asking value of A. What to do friends? Can anyone suggest please? What to do here? Can anyone suggest? What could be the idea? Right? Perpendicular in 2D geometry is easy. M1 into M2. First slope, second slope, product of the slopes is minus 1. Right. So in 3D geometry, how will you apply perpendicularity condition? You know that right angle triangle, 90 degrees perpendicular. Any idea? Quick, just give one hint what to do, what idea to be done. Yeah. Can I expect, my dear friends? Manish, Anshupriya, Newton. Subiksha, come on please. Yeah, the simple idea is, dear students, it is going to be DC's or DR's idea. DR's of AC bar, you just find A minus 2 minus 3 plus 1 is minus 2, 1 minus 1 is 0. Similarly, BC DR's, BC or CB, anything is okay. A minus 1, 0, this is 1 minus of minus 5, 6. So, if two lines are perpendicular, the product of their DR's must be 0, dot product 0, no, the same logic. So, this is going to be A minus 1 into A minus 2 plus 0 equal to 0. A must be 1 or 2. A possibility is 1 or 2. Okay? Yeah. Right, dear students. So, of course, we need to discuss few more questions. The vectors rotated through an angle theta and doubled in magnitude, it becomes this, then the value of x. Let me give the idea, dear students. One vector is given, okay, suppose this is the vector, rotated through an angle theta and doubled in magnitude, then it becomes like this. So, friends, it is doubled in magnitude, rotated through an angle theta, right? Then what could be x value? So, fortunately, x is the only unknown here. So, what I can say is, find its first initial case magnitude you take. So, magnitude is root of 1 square plus 4x square plus 4, yeah, is doubled with its magnitude you write root of 4 plus 2x plus 2 whole square plus 6x minus 2 whole square. Just solve this equation. First magnitude into 2 gives the second magnitude. You will be getting two values for x you can get. In the same way, friends, in fact, I have incorporated few more problems. So, these as well as dot product, cross product, triple product related results will be done in the next class. Right, dear students? Yeah. Actually, I thought of taking the class 2 to 4, so due to some reasons I couldn't take. So, right, tomorrow I will try to take in a full-fledged way. So, I will try to complete the topic vectors, right, dear students. So, the student who followed here can share your experience. So, accordingly I can speed up or I can slow down, I can cover the different kind of content. So, I can mold any of the ways, means what you require. My dear students, I think so you get the clarity about the things, fine, and see you in the next class, dear students. Take care, bye. Tomorrow my class will be math class vectors 2. Take care, bye.